Now we have to define the acceleration. And just like we defined the velocity in terms of, as the derivative of the position, we're going to define the acceleration as the time derivative of the velocity. So if you know the velocity as a function of time, then the acceleration as a function of time is just equal to the time derivative of the velocity. And that's always true. There's no exceptions for that. And what does acceleration mean? Well, you know it because of the derivative relationship. It has something to do with changing velocity. We are going to think of it this way. So it's changing the velocity, and the velocity is related to the speed. If the velocity and acceleration have the same sign, then the object is speeding up. And if, on the other hand, the velocity and acceleration have opposite signs, then it's slowing down. Okay, so let's think for a second. What if the velocity and the acceleration are both positive at an instant? Well, then that means that the thing is moving in the positive direction and it's speeding up. What if velocity and acceleration both have negative signs at an instant? Well, that means that it's moving in the negative direction and speeding up. Okay, so it's a little more subtle. Like if you had to think about it, guess on your own, you might think like, okay, well, if acceleration's positive, it's speeding up, negative, it's slowing down, but that's not quite right. You have to know the directions of the velocity and acceleration to know in what way the speed is changing. The SI units for acceleration are meters per second squared. And let's just like I said with velocity, I want you to think of this definition every time you see a value of acceleration. Think in relationship, think of the relationship between velocity and acceleration. I'm going to give you a couple of examples to sort of cement this idea. So first, let's say that we know that the position as a function of time is equal to negative 10t plus 2t squared. Okay? And what we want to know is what direction is the object moving at time 3 seconds. And then second, is it speeding up or slowing down at time 3 seconds? Okay, well, we know that speeding up and slowing down has to do with the relationship between velocity and acceleration. We have the position, so we know that we can calculate the velocity as a function of time by just taking the derivative with respect to time of this function. And if you take this derivative, you get negative 10 plus 4t. Okay, so that's the velocity as a function of time. And now for the acceleration as a function of time, we can just take the time derivative of the velocity. The derivative of negative 10 is 0. Derivative of 4t is 4. So the acceleration as a function of time is 4. That means that the acceleration is just this constant 4 all the time. Okay. Well, now that we have these functions for velocity and acceleration, we can answer these two questions. So for part A, what direction is the object moving? We're going to plug in 3 seconds to the velocity function. So the velocity when time is equal to 3, one way you could write that is that the argument here is 3 seconds, is equal to negative 10 plus 4 times 3. And so you get 12 minus 10 is positive 2 meters per second. What about the acceleration? The acceleration at 3 seconds, well, we saw that the acceleration at every time is 4, so it has to be 4. And so what direction is the object moving at time 3 seconds? You can look at the velocity and look at the sign, and that tells you the direction that it's moving. So since the velocity is positive at 3 seconds, it's moving in the positive direction. Now I guess I'll make this the start of calculating B. Okay, so is it speeding up or slowing down? Well, velocity and acceleration are both positive. So it's speeding up in the positive direction. Okay. Let's do another example of the type that you'll see in problems. So let's say this time that we start with an acceleration as a function of time that's equal to negative 5t plus 10. And let's say when time is equal to 2 seconds, the object is moving in the negative direction. With a speed of 10 meters per second. So first, let's calculate the velocity as a function of time. And then second, let's figure out whether it's speeding up or slowing down at time 3 seconds. Okay, well, the first thing we want to figure out is the velocity as a function of time. We can't just take the derivative of the acceleration to get the velocity, because that derivative relationship goes the other way. You know, we have this derivative relationship that says the acceleration is the derivative of the velocity, which means that if we want to go the other direction, from the acceleration to the velocity, we have to use an integral. So the velocity as a function of time is the integral of the acceleration with respect to time. Okay, well, let's take the integral of this function. You get negative 5t squared over 2 plus 10t. So I'll write that as negative 2.5t squared plus 10t. And then, as always, don't forget about your constant of integration. That always has a physical meaning for us. Okay, so we almost have the velocity as a function of time, but we don't know what this c is. So how are we going to get that? Well, we're given information that we can use to calculate what that c is. So we are going to plug 2 seconds in for the time, and we're going to use the other information to tell us the velocity. We know that it has a speed of 10 meters per second, and it's moving in the negative direction. So we know that the velocity at 2 seconds is equal to negative 10. Okay, so negative 10 is equal to negative 2.5 times 2 squared plus 10 times 2 plus c. And now it's just a matter of solving for c. Let's see, we got negative 10 is equal to negative 10 plus 20 plus c. Those two cancel out, and we get that c is equal to negative 20. That was the only thing we didn't know yet about the velocity as a function of time. So now we can give our final answer. Velocity as a function of time is equal to negative 2.5t squared plus 10t minus 20. And there you go. That's our velocity function. Now that we have that velocity function, we want to use that to figure out at a different time, 3 seconds, is this speeding up or slowing down? Okay, well, at time 3 seconds, we can plug 3 into this velocity function to figure out what the velocity is. We have negative 2.5 times 3 squared plus 10 times 3 minus 20. And if you plug all that in, you get that the velocity is, I get, does this make sense? Let's just make sure. And for this, I get an answer of negative 12.5 meters per second. Then for the acceleration, I have a function for that too, so I can just plug 3 seconds into the acceleration. And we get negative 5 times 3 plus 10 is negative 5 meters per second squared. Okay, so is this speeding up or slowing down? The velocity and acceleration are both negative. So it's speeding up in the negative direction. It's moving in the negative direction and speeding up.